Strategic bombers loaded with nuclear and conventional weapons cross the skies daily, part of a deterrence routine that defines the balance of power between the major powers. These flights are not isolated exercises. They represent constant presence, rigorous training, and the maintenance of an immediate response capability. Even so, accidents occur with worrying frequency. What makes these aircraft so prone to incidents? And when the worst happens, how do the crew members manage to escape from pressurized cabins at high speed? The era of strategic nuclear bombers began during World War II. The United States developed the Boeing B-29 Superfortress to meet the need for a long-range heavy bomber capable of reaching Japan from distant bases in the Pacific. The project required a range of over 5,000 kilometers with a significant payload, cabin pressurization for high-altitude flights, and advanced defensive systems for that time. The B-29 entered service back in 1944. In August 1947, two modified aircraft, Enola Gay and Bockscar, dropped the first atomic bombs on Hiroshima and Nagasaki, ending the conflict in the Pacific. The end of the war did not diminish the importance of these planes. With the beginning of the Cold War, the United States created the Strategic Air Command to ensure a nuclear retaliation force capable of reaching Soviet territory. The Soviet Union responded by developing the Tu-4, a copy of the B-29 and later jet bombers. The central objective was deterrence, maintaining a credible threat of massive nuclear attack to prevent aggression. Strategic bombers formed one of the three pillars of the nuclear triad, alongside land-based ballistic missiles and submarines, because they offered flexibility, in-flight recall, and a visible demonstration of force. Today, both the United States and Russia maintain active fleets in daily operation. The Americans operate the B-52H Stratofortress, the B-1B Lancer, and the B-2 Spirit, which will be replaced by the B-21 Raider. The B-52H, in service since the 1960s and continuously modernized, carries out missions and global patrols, deterrence exercises, and maintain a continuous presence in the Pacific and other regions. These flights involve frequent takeoffs, in-flight refueling, and long routes that test crews and equipment under extreme conditions. Russia relies on its Tu-95 MS Bear, the Tu-160 Blackjack, and the Tu-22M3 Backfire. The Tu-22M3 in particular is a key piece of Russian long-range aviation. Developed in the 1970s and improved in the M3 version, it was introduced operationally in the 1980s. It has variable geometry wings, two NK-25 engines with afterburners, and the capability to fly at Mach 2 at high altitudes. Its combat radius reaches about 2,000 to 2,500 kilometers with a significant payload, and it can carry up to 24 tons of armament, including supersonic Kh-22 missiles or even the Kh-32, which reaches Mach 4 in the terminal phase, as well as nuclear or conventional bombs. The Tu-22M3 is strategically important for Russia because of its versatility. Because of its versatility, it operates both in deep ground attack missions and has a range of 2,500 kilometers. It is one of Russia's aircraft. It is capable of targeting aircraft carriers. It has been used in various operations, notably in Syria, and is currently launching missiles and bombs against Ukraine. Unlike intercontinental bombers like the Tu-95 and Tu-160, the Tu-22 is optimized for shorter ranges. It is used in theaters but remains essential for regional deterrence and power projection. Its pressurized cabin accommodates 4 crew members: commander, co-pilot, navigator, and weapons systems operator, seated in 2 compartments. Accidents involving the Tu-22M illustrate the inherent risks of operating complex and aging aircraft at an intense pace. In a recent accident in the Irkutsk region, on Monday, June 15, during a training flight, the Russian crew successfully ejected before the aircraft crashed, demonstrating that the system works when high altitude and speed conditions are adequate. The ejection system was manually activated by the commander during the emergency. The KT-1M type seats developed by the Tupolev Bureau follow a specific sequence. First, the navigator operator, then the navigator, next the co-pilot, and finally the commander, who ejects manually. Each seat uses a 2-stage rocket motor to launch the crew out of the cockpit and then to a safe altitude, after which the parachutes deploy. For safe ejection at low altitude, a minimum speed of about 130 to 140 kilometers per hour is required for the parachutes to open properly. Until the mid-1980s, the ejection seats were directed downward from the cockpit compartment, but the Tu-22M version has a traditional upward ejection system. Hours after the incident with the Russian bomber, cockpit, another bomber, this time a strategic one, the B-52H Stratofortress, crashed shortly after takeoff at Edwards Air Force Base in California. Images showed a large column of black smoke. Emergency teams responded immediately. The 8 crew members on board did not survive the crash. Most likely they were unable to eject in time. On the B-52H, the escape system varies depending on the crew's position. On the upper deck, pilot, co-pilot, electronic warfare officer, and, when present, gunner. The seats eject upward after the levers are activated, which eject the upper hatches, followed by the trigger that fires the propulsion systems. On the lower deck, with the navigator and the radar specialist, the seats eject downward through hatches in the fuselage floor, a design necessary because of the limited space above. Modern systems allow ejections at low altitude and even 0 speed in some cases. But the B-52, with more than 60 years of service, operates with updated technology after undergoing a modernization program. Nuclear bombers require constant maintenance of complex systems, flights in extreme altitude, speed, and load conditions, and highly trained crews who operate under intense pressure. The aging of fleets like the B-52, since the 1950s and 60s the Tu-22M from the 70s and 80s, the high rate of use for deterrence and exercises, and the integration of nuclear or precision weaponry increase the risks. Understanding their risks and the crew's survival mechanisms helps to assess the real capability and the limits of these forces. If you're interested in military aviation, Cold War history, or military technology, leave your comment below about what caught your attention the most in this video. It's always an honor to bring exclusive analyses to you. Don't forget to support us. Donate any amount to us. Our Pix payment key.
canal areamilitaroff@gmail.com